exchanged a single photos and then continued on their way. Time goes from left to right. The wiggly line is a photos, and the solid lines show the elections marked as E. The diagram includes all the cases where the burdens travel up to down or down to up. What is why the wiggly line is drawn vertically? Most completed processes have more than one of the built particles in more complex Benjamin diagrams. For example, here is one with two bitrole photons and two bitrole electrons. An infinite number of many diagrams are needed to fully describe each kind of particle reaction. Though technically, scientists can often obtain very good approximation by only using the simplest one. Here's one that called reflectant water cloud. The U, D, and B are quarks, while G shows gluons. Be telling the truth? If so, this word would be first time he wasn't concealing some deadly trick. Intended to experiment Eric and even off the scores. He looked over at River, but something had happened to him while George was absorbed in his thought. He seemed to be fading, disappearing into the blackness of the Andromeda galaxy around him. George said urgently, "We have less time than I thought. What's happening to you? I'm not real." River was talking very fast now. George could no longer see his outline, only small triangles of reflected starlight on his shiny helmet and boots. "I'm a computer-generated avatar of myself. It was the only way I could meet you. When I couldn't find Fugi or Eric or Cosmos, I broke into your house and secretly left a rerouter downstairs. Through that rerouter, I used Boogie to send myself here and open the portal remotely to transport you. Why don't you avatar yourself to the collider and tell them?" cried George. "Why me? I cannot get to the collider," said the River, his voice distorting. "I will not be able to escape them again." "What about the quantum medical bomb?" cried George. "There's a way. I'm a complete fool. I made an observation. Pookie sent you a code." "What? How do I use Pookie code? How do I defuse the bomb?" But the only reply George got was faint whisper through his voice transmitter. "George." And with that, the universe around him fell silent. In front of him, where the river had stood, the silvery tunnel had opened up once more, pulling him toward into its river of light. He twisted and turned at unimaginable speed across the universe, flying quintillions of millions of Andromeda back to our own galaxy. The Milky Way, which is made of matter and dark matter. That mysterious dark substance that surrounds us, but which we can't see, feel, or hear. As he traveled, a thought flew into his brain. "I have been to the dark side," he said to himself. "I have been to the dark." The latest scientific theories. The dark side of the universe. One of the simplest questions we can ask it. What is the world made of? Long ago, the Greek Democritus postulated that everything is made of indivisible building blocks he called atoms, and he was right. And over the past 2,000 years, we have filled in the details. All the stuff in our everyday world is made of combination of the 92 billion different types of atoms. The elements of the periodic table: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, and all the way up to uranium. Number 92. Plants, animals, rocks, minerals, the air we breathe. And everything on Earth is made of these 92 building blocks. We also know that our Sun, the other planet in our solar system, and other stars far away are made of the same 92 chemical elements. We understand the atoms very well and are masters and relating them into all kind of different things, including my favorite, French fries. The science of chemistry is all about building different things with atoms, a kind of Lego with atoms. Today, we know that there is a whole lot more out there than just our solar system, the mind-bogglingly large universe, with the billions of galaxies, each made of billions of stars and planets. So, what is the universe made of? The surprise, while our solar system and the other stars and planets are made of atoms. Most of the stuff in the universe is not. It is made of very strange stuff, dark matters and dark energy that we do not understand as well as atoms. First, numbers in the universe as the whole atoms around account for 4.5%. Dark matters for 22.5%, while dark energy is at 73%, and inside, only about 1 in 10 of those atoms is in the form of stars, the planet, or living things, with the rest existing in a gaseous from too hot to have made stars and planets. Let's begin with dark matter. How do we know that it's there? Well, what did it? And what's it? What did it? And how come we don't find it on Earth or even in our sun? We know it is there because the force of its gravity holds together our galaxy, the Andromeda galaxy, and all the other big structure in the universe. The visible part of the Andromeda galaxy and all other galaxies sits into the middle of an enormous 10 times larger sphere of dark matter. Astronomers called it the dark halo. Without the gravity of the dark matter, most of the stars, the solar system, and everything else in the galaxies would go falling all over the space, which would be a very bad thing. At the moment, we don't know exactly what the dark matter is made of. Not unlike Democritus, who had an idea, atoms, but didn't have the details. But here is that we do know. Dark matter particles are not made of the same parts that atoms are: protons, neutrons, and electrons. It is a very new form of matter. Don't be too surprised. It took nearly 200 years to identify all the different kinds of atoms, and Over the course of time, many new forms of atomic matter were discovered. Because dark matter is not made of the same pieces as atoms, it is, it is very much analogous to atoms, and vice versa. Moreover, dark matter particles are analogous to other dark matter particles. A physicist would say that dark matter particles interact with atoms and evolve themselves very quickly, if at all, because of this fact. When our galaxy and other galaxies form, the dark matter remained in the very large and diffuse dark matter halo, while the atoms collided well one another and sank to the center of the dark halo, eventually forming stars and planets made almost completely of atoms. The shyness of dark matter particles then is why stars, planets, and we are made of atoms and not of dark matter. Nonetheless, dark matter particles are buzzing around our neighborhood, and in any given time there is about one dark matter particle in a good-sized tea cup. And this is the key to testing this bold idea. Dark matter particles are shy, but can occasionally leaving a telltale signature in a very sensitive particle detector. For this reason, the physicists have built large detectors and placed them in the underground to shield them from the cosmic ray that bombard the surface of the universe, Earth, to see if dark matter particles really do confuse our halo. Even more exciting is creating new dark matter particles to add particles isolators by turning energy into the mass. According to Einstein's famous formula, E equals mcc. The large hard collider in Geneva, Switzerland, had the most powerful particles isolators ever built, is trying to create the detect dark matter particles, and the satellites in the sky are looking for pieces of atoms that are created by dark matter particles in the hollow occasionally collide and produce ordinary matter. The result of what the particles isolators are trying to do. If one or more of these methods are successful, and I hope that at least one will be, we will be able to confirm that something over the atoms make of the bulk of the matter in the universe. Wow! And now we are ready to talk about the biggest mystery in the science, the organic. This is such a big puzzle that I am confident it will be a round of one of you to solve. Solving it, might even the people, even the thoughtful, the Einstein's theory of gravity. Mm, General the reality. We all know that the universe is expanding. Mm, Having grown in size for the past fast 13.7 billion years after the Big Bang. Since Edwin Hubble discovered the Big Expansion more than 80 years ago, astronomers have been trying to measure the slowing of the expansion due to the gravity. Gravity is the force that holds off to the key Earth, keeps all the planets orbiting the sun, and is generally nature's comic glue. Gravity is an attractive force. It pulls things together, slows down volts and rockets that are launched from Earth, and so the expansion of the universe should be slowing down due to all the stuff attracting all the other stuff. In 1998, the astronomers discovered that this simple but very logical idea couldn't be more wrong. They discovered that the expansion of the universe is not slowing down, but instead it is speeding up. They did this by using the time machine aspect of telescopes, because light takes time to travel from across the universe to us. When we look at the distant object, we seem to them as they were long ago. Mm, Using powerful telescopes, include the Hubble Space Telescope, they were able to determine that the universe was expanding more slowly long ago. How can this be? According to Einstein's theory, some stuff even weirder than dark matter, has repulsive with gravity. Repulsive gravity means gravity that pushes things apart rather than pulling them apart together, which is very strange indeed. It goes by the name of dark energy and could be something as simple as the energy of quantum nothingness, or as weird as the influence of additional space-time dimensions, or the maybe no dark energy at all. And we need to replace Einstein's theory of general relativity with something better. Part of what makes dark energy such as important puzzle is the fact that it holds the fate of the universe in its hand. Right now, dark energy is stuffing on the gas pedals and the universe is speeding off, suggesting to suggesting that it will expand forever, with the sky returning to darkness in about 100 billion years. Since we don't understand dark energy, we don't rule out the possibility that it will put its foot on the brake at some time in the future, perhaps even causing the universe to collapse. These are all challenges for the scientists of the future. You maybe to explore and understand. Michael.